So normally we leave the touchy-feely emotions things out of math class and let you deal with that in Mrs. DiGirolamo's language arts class. But today we're going to take a little bit different approach. I'm going to ask a question: is math beautiful? Before you laugh, which I'm sure you are, let me show you a couple examples that might give you some thoughts there. So think about your definition of beauty. If you take a look around the world at things that we deem as beautiful, for instance, the Acropolis, an ancient Greek structure. It was the temple built by the Greeks to honor the goddess Athena. And this was built in the BCs, so thousands of years ago. If you look at the structure of this building, that didn't have any lasers or anything like that, no modern construction materials or anything like that. But if you look at some of the pictures of this thing, or just look at it from an aerial shot, the symmetry is really quite remarkable. It's very beautiful how this is set up. If you look at some of the pictures, it's in perfect proportion. The top, I forget what it's called here, but the columns are in perfect proportion, the triangular part above. This thing was a football field long, and if you looked at it from the front, you would be able to see the statue of the goddess sitting in the back all the way through. So that's just one example. Think about your definition of beauty. What draws the human eye? Here's a picture of a famous actress that you all know, Jessica Simpson. This is a famous example. The Greeks studied a ratio called the golden ratio. The Greeks were very, very interested in the concept of perfection. The golden ratio applies to any number of different objects, but essentially what you see here in the picture below with Jessica's face is we've taken and applied that ratio to her forehead, her eyes, and then you'll notice what we find is that her facial features are perfectly lined up with where the human eye expects them to be. So just the concept of symmetry does have a lot to do with art, but it also has to do with math. Let's take a look at a couple examples here. There are two types of symmetry. The first is line symmetry. Line symmetry is very basic. Basically, if you could draw a line through it so the two sides are mirror images, it has line symmetry. You look at this Arctic tern here, this bird. It shows up in nature a lot. If this thing was out of balance, if one side was different from the other side, you wouldn't be able to have the flight of birds. Taking a look back at architecture, the Taj Mahal. This is the biggest tomb ever built. This again was made in the BCs, no modern architecture here. But this is actually, man made this as a memorial and actually as a tomb for his wife. And this is not a painting. These are actual pictures of the Taj Mahal. You notice how perfectly lined up everything is. Even from the side, you can see everything, even the windows, everything lines up so it's mirror images. A little bit more recent architectural wonder, you look at the National Mall in Washington, D.C. National Mall, some of you, I'm sure you've been there. If you take and draw a line from the Capitol building all the way down the National Mall, it runs through the Washington Monument, through the reflecting pool, all the way to the Lincoln Memorial. So you can stand in the Lincoln Memorial and see the Capitol building there. Let's talk about how, it's pretty easy to identify line symmetry. Let's talk about how, if you're missing half of an object, how do you complete it? One thing to do is to identify these key angles, and that's what I'm doing here. Where do the lines turn? Where do the angles happen? I always draw little dotted lines straight down past the line of symmetry there, and try to keep everything kind of the same distance. I'm not doing a great job here, but try to keep everything the same distance. Notice how that horizontal line there is the same distance from the horizontal line above it, or at least it is. Notice the angles where the front of the rocket ship goes into the line of symmetry is the same angle coming out. Where on the back of the rocket ship, the tail goes from the horizontal line and angles downward, we keep the same angle there as well. So make sure your angles are the same. If you finish and the top doesn't look like the bottom, You did it wrong. Letter B. Notice there's no angles here, but there is that curve. So if I draw a dotted line straight across, that's going to tell me how far down to dip that curve. And then if I draw a dotted line, I'm just going to draw a line from the bottom here first. Let me switch colors. I can draw this line so it's the same length as the other side. Draw a dotted line across the top. That'll tell me how far up to bring the horizontal or the vertical line there. And then just try and copy the curve there. And notice we get a symmetrical shape, somewhat symmetrical. The other type of symmetry is called rotational symmetry. Keyword here is rotate. What this means is that if you have a figure where every so many degrees the pattern repeats as you move around in a circle this time, rather than just being able to fold it over and have one be a mirror image of the other, the pattern repeats every so often, every so many degrees. So you notice this snowflake here, notice the pattern repeats 8 times for the different parts of the snowflake. That's why we call it 8-fold rotational symmetry. If I take the first fold there and rotate it, 1 lands on top of 2, would then land on top of 3, all the way across the circle. You see this in nature as well. Notice the starfish here. I can split this up from the center of the starfish, and notice the pattern repeats 6 times. This is 6-fold rotational symmetry on a starfish. The object on the right is a beehive, actually one of the strongest structures per mass. So for its mass, it's one of the stronger structures in nature. This might change your mind about eating honey, but it's made entirely out of bee spit and other materials like that. So very interesting stuff here. Again, 6-fold rotational symmetry. A little bit harder to spot, but if you'll notice it has a structure like this, you know it has rotational symmetry. Let's take a look at a couple examples of how we repeat this. When we do this, the first thing we're going to do is we're going to figure out how many times this is going to repeat as we move around the circle. To do that, we need to remember that a circle is 360 degrees. So in other words, if I take this object, I'm just going to duplicate this and rotate it. Notice it's going to rotate around that dot there. That's the center of rotation. It's not perfect, but you notice there we have 2-fold rotational symmetry. And it's 2 folds. Notice it rotates every 180 degrees. So it's going to turn 180 degrees and repeat itself that way. Let's look at how we draw this if you don't have a Promethean board, because that's what you're going to have to do. So to do this, basically look how we have this L shape. If I do 180 degrees, I'm going to have to repeat this the other way. So I'm going to take the line below the dot and make that above the dot. I'm going to take that long line, or that short line that goes from the top, and draw that on the bottom now. Notice it's the same distance down from the dot. So everything, I'm referencing the dot and how far down I go. So basically you want to try and copy everything, but copy it as if you're in a mirror. Notice keep the widths of the L shape the same distance here. Do your best to keep it the same. 5-fold, that's a little bit more difficult. But I can do 360 divided by 5, and I get 72 degrees. So this diamond, and it's not a diamond, but this shape is going to repeat every 72 degrees. And you'll notice that this angle right here, where it opens up, I can repeat that, and that's actually 72 degrees. So if I repeat that angle 5 times, this object will be 5-fold rotational symmetry. Let me repeat that over here. So I'm up to 3. Then I've got the bottom. All right. Yeah, do your best with that and see how far you can get. I can't remember if those objects there are in your note sheet or not, but if they are, try your best to complete those. You have some book work to do in blended schools. Along with this, you also have your transformation project to work on. So go ahead and get started on that once you have all your notes completed.